the specification for GCSE also wants you to know what these exact values are. So these are values that you should memorize for the exam. So how this table works is we can get sine from here, and we know that sine 0 is 0, sine 30 is a half, sine 45 is 1 over root 2, sine 60 is root 3 over 2, and sine 90 is 1. And similarly for cos and tan. Something quite interesting is that tan 90 doesn't exist. And that's because if we go back to the graphs, we can see that tan 90 actually goes to infinity. So we can't actually define that. Now, one method would be to use this table, but I feel as if that can be quite difficult because you're memorizing so many values. So what you can do is you can use these triangles, and all you have to do is learn 2 triangles to know these values. So first off, let's consider an equilateral triangle. So as we determined before, these have 60 degrees on either side. And let's say it has a length of 2. Now what we can do is we can split this in half to get a right angle here. So if we bring this here, just the right angle we're focused on. So we have 60 degrees. Actually, let me make that a little bit bigger. So we have 60 degrees here and 30 degrees here, because remember we're halving this angle. And we still have 2 here, but remember because we're halving this length we have 1. And then using Pythagoras we can figure out that this side here is root 2 squared minus 1 squared, which is root 3. Right? So you don't really need to know how we get there, but it's helpful to imagine it imagine it like an equilateral triangle of length 2. So once we have this right angle, we can use our SOHCAHTOA rules to figure out any value from that's 30 degrees or 60 degrees. So let's say if we wanted to find, I don't know, let's do tan 60, right? So tan 60 would be opposite the 60 degrees. So that's root 3 over the adjacent, which is 1. By the way, I'm just using the formulae we learnt before here in red. So that equals root 3, and you can see it's correct. Right. So what you might be wondering is, okay, we know how to do 30 and 60 degrees. How about 45 degrees? Well, that's where this second triangle comes in. Now just consider the right angle with side lengths 1. And then what we can say is, because these two are the same, we have an isosceles triangle, correct? So these two angles must be the same. And by using the fact that there are 180 degrees in a triangle, we know that these two must be 45. And also using Pythagoras, we know this will be root 2. So for example, let's figure out cos 45. Well, that's going to be SOHCAH, so it's going to be adjacent. We can use any angle really, and we get 1 over the hypotenuse, which is root 2. And see, we get this exact value. So you can use these two triangles to figure these out. Another thing you might be thinking about is, okay, we know how to do these, but how about sine 0 and 90 degrees? Well, we don't actually need the triangles for this, nor could we really use the triangles. But what we can do is we can use the graphs, because remember, we know that sine 0 is at 0 and sine 90 is at 1. And we know that cos 0 is at 1, and cos 90 is at 0. And we know that tan 0 is at 0, and obviously tan 90 doesn't exist, like we mentioned earlier. Okay, now you can try these exercises here.